Hello guys, I'm going to start today a new topic that is hierarchical clustering. Means suppose we have 5 points A, B, C, D, E. Hierarchical clustering is a popular method for grouping objects. It creates groups so that objects within a group are similar to each other and different from objects in other groups. Clusters are usually represented in a hierarchical tree called dendrogram. The sole concept of hierarchical clustering lies in just the construction and analysis of a dendrogram. The dendrogram is a tree-like structure that explains the relationship between all the data points in the system. These are the data points. Data points 1, 2, 3, 4, 5, and 6. Types of hierarchical clustering. First, divisive clustering. Second, agglomeratic agglomerative clustering. This follow top to down approach. This follow bottom to up approach. Start with one all-inclusive clusters. Starts with the points as individual clusters. At each step, split a cluster until each cluster contains a point, or there are k clusters. At each step, merge the closest pairs of clusters until only one cluster left. Traditional hierarchical clusters use a similarity or distance matrix. Merge or split one cluster at a time. L ag, agglomerative clustering and divisive clustering. Sign bottom to up, top to down. Next, strengths of hierarchical clustering. Don't have to assume any particular number of cluster. First, keep in mind, not like K means clustering. Any desired number of cluster can be obtained by cutting the dendrogram at the proper level. They may corresponding to the meaningful they may correspond to the manifold taxonomies, example in biological sciences. Agglomerative clustering. More popular hierarchical clustering technique. Key operation is the computation of the proximity of two clusters. Different approaches to defining the distance between clusters distinguish the different algorithms. Basic algorithm is straightforward. Compute the proximity matrix. You might have doubt what does it mean. Definitely I would explain it. Let each data point be in let each data point be a cluster. Repeat, merge the two closest cluster, update the proximity matrix until only a single cluster remains. Starting situation. Start with clusters of individual points and a proximity matrix. Proximity matrix like this. It seems like this. P1, P2, P3, P4, P10, P11. Intermediate situation. After some merging steps, we have some clusters. C1, C2, C3, C4, C5. Proximity matrix. We want to merge the two closest clusters C2 and C2 and C5 and update the proximity matrix. After merging, the question is how do we update the proximity matrix? How to define inter-cluster similarity? Mini, max, group average, distance between centroids, other methods driven by an objective function. What's method use squared errors? Minimum, maximum, group average. Distance between centroids. Single link, complete link. Another way to view the processing of the hierarchical algorithm is that we create links between their elements in order of increasing distance. The minimum single link will merge two clusters when a single pair of elements is linked. The max complete linkage will merge two clusters when all pairs of elements have been linked. How to create dendrogram mathematical institution. 3210.134.1352 5 and 3 3 and 5 2 diagonally distance of all the points will be 0. This, 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 this. Distance P1, P2, P5. This has become one cluster P1. This minimum of P1, P3, or P1, P5. Minimum 3 P1, P3, P1, P5, P1, P3. This minimum 3. Distance P2, P3, P5. Minimum P2, P3, P3, P5. Distance P3, P5, P4. And P2 and P4. Distance P2, P1, P3, P5. Distance D, P2 and this. Now the new cluster will be cluster similar group average. This is I have given overview and this is little bit might be you get new to digest it. Don't worry, I definitely design in such a way you definitely get the things. Look at this. Once again, revise the entire lecture. Once again, hierarchical clustering. Suppose we have 5 points A, B, C, D, E. Hierarchical clustering is a popular method for grouping objects. Hierarchical clustering is a popular method for grouping objects. Hierarchical clustering is a popular method for grouping objects. It creates groups so that objects within a group are similar to each other and different from objects in other groups. Means this group has some similarity, this has group some similarity, but the similarity of this group and this group are different. Okay. And then this group and this combine of this group have some similarity. That is why they have cluster over in one group. And the entire means this one and this one has some other similarity, and that is why it has been covered in this big one cluster. Mm, Meaning, try to understand the meaning. Okay, my objective to deliver this lecture to make you ready for interview. If you are ready, if you have those knowledge which are concrete and solid, then no one stop you to qualify the interview. Okay, okay, guys, let's continue once again. Suppose we have 5 points: A, B, C, D, E. Hierarchical clustering is a popular method for grouping objects. If someone asks what does it means by hierarchical clustering, we have to tell this is the method to grouping objects. If you want to group the objects, you can use this type of clustering. For which purpose? Grouping objects. You can use this for grouping objects only. You can use this for grouping objects only. What purpose you can use this for grouping objects only? It creates groups so that objects within a group are similar to each other and different from objects in other groups. This is clearly written here. Create groups so that objects within a group are similar to each other and different from objects in other groups. Okay, you have to get meaning of this. It creates groups so that objects within a group are similar to each other and different from objects in other groups. Are you getting meaning? Tell yes or no. It creates groups so that objects within a group are similar to each other and different from objects in other groups. It creates groups so that objects within a group are similar to each other and different group objects in other groups. It creates groups so that objects within a group are similar to each other and different from objects in other groups. Clusters are visually represented in a hierarchical tree called dendrogram. Clusters are visually represented in a hierarchical tree called dendrogram. Clusters are visually represented in a hierarchical tree called dendrogram. This is dendrogram. This is dendrogram. This is dendrogram. The cell The sole concept of hierarchical clustering lies in just the concentration and analysis of a dendrogram. The sole concept of hierarchical clustering lies in just the concentration and analysis of a dendrogram. Okay, the sole concept of hierarchical clustering lies in just the construction and analysis of dendrogram. The sole concept of hierarchical clustering lies in just the construction and analysis of a dendrogram. A dendrogram is a tree-like cluster that explains the relationship between all the data points in the system. A dendrogram is a tree-like structures that explain the relationship between all the data points in the system. A dendrogram is a tree-like structure that explains the relationship between all the data points in the cluster. A dendrogram is a tree-like structure that explains the relationship between all the data points in the cluster. A dendrogram is a tree-like structure that explains the relationship between all the data points in the system. Are you getting me? Try once yourself. Try once again. A dendrogram is a tree-like structure that explains the relationship between all the data points in the system. Today I am going to conclude lecture here, and next lecture I would continue from here. Okay guys, thank you.